So in this question we have been said that triangle ABC is right angled at B. We have been given that tan of A is 1 by root 3 and we have to find the values of the two expressions that are written here. So there are two parts for it. So before we calculate the values of each part, we need to first analyze angle A, angle C and then their trigonometric ratios. So I'll draw a right angle triangle. So this is a right angle triangle A, B, C, since it is said that it is right angle at B, so it is right angle at B. Now for this angle 90, this would certainly become the hypotenuse. Now it is given that tan of A, so I'll mark angle A. For this angle A, BC would behave as the perpendicular and AB would behave as the base. Therefore it is given to us that tan of A is equal to 1 by root 3. Now tan is the ratio between the perpendicular and the base. Therefore let P be equal to x. Therefore B would be equal to root 3x, so that the ratio becomes 1 by root 3 and x is their common factor. So in the diagram I'll show this as x and this is root 3x. Now our objective would be to find hypotenuse. So applying the Pythagoras theorem, which is h square is equal to p square plus b square, I'll get h square is equal to x square plus root 3x whole square. This is x square plus 3x square, which is equal to 4x square. So I'll get h square is equal to 4x square, and that would give me the outcome that h is equal to 2x, because under root of 4 would be 2 and the under root of x square would be x. Therefore this is equal to 2x. So primarily I have first found out the three sides of the triangle ABC. So I'll draw this diagram once again. So we have this triangle ABC right angle at B. If I refer back again, P was x, this side BC was x, AB was root 3x. So this was x, this was root 3x, and we calculated the length as 2x. Now I'll first go ahead with the first expression that we needed to find out. The first expression was sine of A cos of C plus cos of A sine of C. So it is sine of A cos of C plus cos of A sine of C. I need to find out the value of this expression. So I need to first find out sine A. Now for angle A, the perpendicular would be BC, hence it is x, and the base would be AB, which is root 3x. Therefore sine A, which is perpendicular upon hypotenuse, would be equal to x, which is the perpendicular, and hypotenuse would be 2x. Similarly cos C, cos is the ratio between the base and the hypotenuse, but for angle C, the perpendicular would be the side in front of it. Therefore for angle C, AB would behave as the perpendicular, which is of length root 3x, and base would be BC, which is of length x. So for angle C, cos of C is base upon hypotenuse. Base is x and the hypotenuse remains same as 2x, plus cos of A. Now cos of A, for angle A, cos is the ratio between base and the hypotenuse, so it would be base is AB, which is root 3x, upon hypotenuse, which is 2x. Similarly sine of C, sine is the ratio between perpendicular and hypotenuse. For angle C, the perpendicular is AB, so it is root 3x upon AC, which is 2x. Hence simplifying, I'll get 1 by 2 into 1 by 2 plus root 3 by 2 into root 3 by 2. This would be 1 by 4 plus 3 by 4. The answer would be 4 by 4, which is equal to 1. Same is the case with the second expression. Now the second expression is cos A cos C minus sin A sin C. So it is cos of A cos of C minus sine of A into sine of C. Cos A. Cos is the ratio between base and hypotenuse. For angle A, the base is root 3x. Remember, the hypotenuse remains same. The hypotenuse is 2x. Now cos of C. Cos is the ratio between base and hypotenuse. It is x upon 2x. Minus sine is the ratio between perpendicular and hypotenuse. The perpendicular is, for angle A, is x. So it is x upon hypotenuse is 2x. Sine of C. Now for angle C, the perpendicular is root 3x and the hypotenuse is 2x. Simplifying, I'll get x would cancel root 3 by 2 into 1 by 2 minus 1 by 2 into root 3 by 2. This would come out to be root 3 by 4 minus root 3 by 4, and the final answer would come out to be